Welcome statistics enthusiasts. Hello students. Today we will embark on a journey to understand the standard normal distribution, the quintessential bell curve that permeates various disciplines. This special distribution serves as the foundation for analyzing data that follows a normal distribution, a common occurrence in real-world phenomena. By understanding the standard normal distribution and its properties, we can unlock powerful tools for interpreting data and drawing meaningful conclusions across numerous fields. So, what is standard normal distribution? Standardization is the process of transforming this variable to one with a mean 0 and a standard deviation of 1. This simple formula allows us to do that. Logically, a normal distribution can also be standardized. The result is called a standard normal distribution. In the last section, we explored shifts in the mean and the standard deviation. So if we shift the mean by nu and the standard deviation by sigma, for any normal distribution, we will arrive at the standard normal distribution. Great. We use the letter z to denote it as said previously. It does mean is 0 and its standard deviation is 1. The standard variable is called the z-score and is equal to the original variable minus its mean divided by its standard deviation. The standard normal distribution is a specific type of normal distribution with defining characteristics. The standard normal with defining characteristics. Mean of 0. The center of the bell curve, also known as the mean, is positioned at 0. This signifies that when data is expressed in terms of standard normal distribution, z-scores, the average value lands exactly at 0. The standard deviation, which reflects the spread of data around the mean, is equal to 1 in the standard normal distribution. This specific value allows for easier calculation and comparison when working with z-scores. We will explore further in upcoming slides. The total area under the curve of the standard normal distribution integrates to 1, signifying the certainty that a data point, when expressed as a 0, will fall somewhere within this distribution. So the question arises, why standardize? Standardization allows us to compare different normal distributed datasets, detect normality, detect outliers, create confidence intervals, test hypotheses, perform regression analysis. So characteristics: mean mu is equal to 0, standard deviation is equal to 1, it has symmetry, it is a bell-shaped curve, and it is continuous. Properties: about 68% of the data falls within first standard deviation of the mean, 95% of the data falls within second standard deviation of the mean. The mean, median, mode are all equal. Z-score, the bridge between data and the standard normal distribution. Z-scores act as a bridge between a specific data point x from a normal distribution and the standard normal distribution. They tell us how many standard deviations that data point lies away from the mean of the original distribution. The z-score formula helps us calculate this distance. Imagine a student's exam score in a class that follows a normal distribution. By calculating the student's z-score, we can determine how many standard deviations their score is above or below the class average. For instance, a z-score of 2 indicates that the data point is 2 standard deviations above the mean in the original distribution. Conversely, a z-score of minus 1.5 signifies that the data point falls 1.5 standard deviation below the mean. Finding probabilities in the standard normal distribution table. The standard normal distribution table or its equivalent function on most calculators is a powerful tool for finding probabilities associated with z-scores. The table is structured with rows representing z-scores and columns showcasing decimal places. To find the probability of a specific z-score, locate its corresponding row and column in the table. The value at that intersection represents the probability density, which translates to the likelihood of encountering a data point within that particular range under the standard normal curve. For example, if a z-score is 1.28, looking up this value in the table might provide a corresponding probability density of 0.8944. This signifies that there is 89.4% chances of probability. Uses. Standard normal distribution has several important uses in statistics. Standardization. It allows for the standardization of normal distribution within different means and standard deviations, making it easier to compare and analyze data from different distributions. Probability calculations. The standard normal distribution table can be used to calculate probabilities for different ranges of values in a normal distribution. Hypothesis testing. The standard normal distribution is used in hypothesis testing to determine the probability of obtaining a certain result by any chance.